Hey guys, it's Mr. Lum here, and we're going to be continuing on about trigonometry, and in particular talking about sine ratio. So first off, we should be on page 11, I believe, of our workbooks. So if you would like to take your workbooks out and flip to page 11, you should see this at the very top of page 11. So it says for each triangle below, name the hypotenuse, the side opposite to the angle marked theta, and the side adjacent to the angle marked theta. So I'm going to do the first few here, and then you're going to do the rest. So here's theta. There's my cat. So here's theta, and so that's, in other words, that's the angle of interest. And so the first one is the hypotenuse. The hypotenuse is always directly across from the 90 degrees. So I'm going to write that. Here is the hypotenuse. And the opposite is marked directly across from the angle of interest, which happens to be this one right here. So this is the opposite. And then the adjacent is the side that is touching theta, but is not the hypotenuse. So here's the adjacent. So I might have gone a little bit quick, so we'll do that again over here with B. So again, the hypotenuse is the longest side, and if you have a hard time seeing the longest side, it is the side that is opposite to the 90 degrees. So opposite to the 90 degrees is this one right here, is the hypotenuse. And then the opposite to theta is, we just call the opposite. Okay. And then that leaves the adjacent. Okay, so C, opposite to the 90 degrees, is the hypotenuse. Opposite to our angle of interest is called the opposite, and that leaves the adjacent right there. Last one, 90 degrees. Opposite to the 90 degrees is the hypotenuse. Opposite to the angle of interest is called the opposite. And then the one that is left over, this side right here, is called the adjacent. So what I want you to do is put the video on pause, and I want you to complete the rest of this section right here and label the triangles. Okay. Now that you're hopefully done that, we're going to actually start using the sine ratio. Now, so here we have a triangle. It says 6.4, 7.3, and 11.2 are the three lengths of it. It says label the triangle according to the angle of interest, and in this case, our angle of interest is A. So just to help us to make it similar to the last one, here is A, which is our angle of interest. And I'm just going to put that theta right here. That's our theta, which is our angle of interest. So we're going to label our triangle. Here is the hypotenuse. Opposite to our angle of interest is the opposite. And the one that's left over is the adjacent. So my first step, so this is how you answer a sine kind of question. Label your triangle. Write down the required formula. Oops. So sine A, or you can say sine theta, doesn't matter. So sine theta is happens to be this. You can write A if you want. Equals, and the formula for sine ratio is opposite over hypotenuse. when we're dealing with sine, we actually don't even need the adjacent. It's just opposite over hypotenuse. So sine theta equals opposite over hypotenuse. Fill in the known values and leave the unknown value. So we know what the opposite is. It's 7.3. So I'm going to fill in that one, 7.3. We know what the hypotenuse is. It's 11.2. So divided by 11.2. We do not know what theta is. So I'm just keep it as sine theta. Now, for the next step, what we have to do is we're going to solve it. So I'm going to go sine theta. Now, what I'm going to do with that 7.3 divided by 11.2 is I'm just going to divide them. I'm going to go 7.3 divided by 11.2, and I have a calculator right here. I push equals, and I get 0.65179. Okay? So that's what I have. Now I haven't found my answer yet. I need to find theta, and this is what sine theta equals. So remember, we have to use shift sine, or in other words, the button sine -1. So some people might have to say shift sine or second function sine to access sine -1 here, or in other words, the inverse function of sine. And so what's going to happen is that's going to equal, we have sine -1 and just regular sine right here. They're going to cancel each other out, and that's going to be left with theta equals sine -1, 0.65179. So I type that into my calculator, sine -1 of 0.65179, and I get theta equals, or A equals, theta equals 40.67, or actually if I round it, for me I get 40.68. So in other words, this angle right here, theta, is 40.68 degrees. Okay, so there's a couple of practice questions right there. I want you to put the video on pause. Hopefully you've written down these notes right here, and I want you to do those practice questions right there and see if you can do it. Okay, hopefully you did those okay. Now, we have like a very similar question here, except we want to know, we know what the angle is, we want to know what the side is. So we have the same formula, sine C or sine theta equals opposite over hypotenuse. It's always going to be opposite over hypotenuse. So the first thing is label the triangle. Here is the hypotenuse because it is opposite to the 90 degrees. Here is C, and C is going to be our opposite. It's our opposite because it is the opposite to our angle of interest. And that leaves this one to be the adjacent, and we don't need to know the adjacent right now. So we're going to write down our formula. Sine theta equals opposite over hypotenuse. We fill in everything that we possibly know. Sine, we know what theta is this time. Theta is 46. Opposite, we don't know. So I'm just going to write opposite. You could write little c if you want. And then the hypotenuse, we do know. It's 4.3. So now what we need to do is we need to solve it. So sine 46, I'm going to type that into my calculator, and I go sine 46, and I press equals. when I type in sine 46 and press equal, I get 0.7193. And that equals opposite over 4.3. Now, if I want to get this 4.3 moved over to the other side, well, what I'm going to do is I'm going to times this by 4.3. If you remember, if I do that to one side, I must do it to the other side. So that cancels out. And then I go 4.3 times 0.7193. And I get 3.093 equals the opposite. And that's my answer. So if the hypotenuse here is 4.3, what's the length of the opposite? It's 3.093. And I should be writing centimeters, because this is written in centimeters, so that means the unit for this one right here should also be centimeters. Okay, so now that you have a written out example, you have a couple of practice questions that you can work on, and hopefully you can make your way through those ones. So put the video on pause and try to do those practice questions. They should be very similar, except that the numbers have now changed. Okay, here's our last example. It's on page 14, and we have the same thing right here, but this time we're looking for the hypotenuse. So same thing, label your triangle. Always start by labeling your triangle. So here is the hypotenuse. It's the opposite to the 90 degrees. Here's my angle of interest. So that means this one way over here is the opposite, and this one is the adjacent. So I write my formula out. Sine theta equals opposite over the hypotenuse. Fill in everything I know and leave what I don't know. So do I know theta? Yes. It's 65. So I'm going to write sine 65 equals the opposite. We know what the opposite is. It's 6. We don't know what the hypotenuse is, so I'm just going to write hypotenuse. Now, I'm going to solve for the hypotenuse. So the first thing I should do is type in sine 65. So in my calculator, I write sine 65, press equals. Please remember, I forgot to say this earlier, but make sure that your calculator is in degrees and it is not in radians or gradians. If it's in radians, then you'll get the wrong answer. Well, you'll get an answer that's in radians, not degrees. So anyways, so I type in sine 65 and I get 9063. And that equals 6 over the hypotenuse. So now that I have that, I need to solve for the hypotenuse. So I'm going to show you the correct method to do. The hypotenuse is on the bottom, so in order to get rid of it, I'm going to times by the hypotenuse. If I do that on one side, I must do it to the other. So I times both sides by the hypotenuse. That cancels out this hypotenuse, and then what I'm left with is I'll write it over here. So I'm left with the hypotenuse times 0.9063, and that equals 6. I then divide by, because I want to isolate the hypotenuse, I then divide by 0.9063. If I do that on one side, I must do it on the other side. That cancels these ones out, and then I'm left with the hypotenuse equals 6 over 0.9063. I type in my calculator 6 divided by 0.9063, and I get 6.62. Since this answer is in feet, my answer should also be in feet. So 6.62 feet is the length of the hypotenuse. Okay, so again, you should hopefully be able to do the next few questions and make your way through the sine section of the worksheet.